Okay, good afternoon. Happy to see all you folks here today. You're here for building great touch systems, and my name is Jerry Ko. I've been in Microsoft for about 15 years, with half of that being in Windows. In the last release, I actually worked on refreshing the networking user experience, Logon UI, Ubi, as well as Home Group. I spent the last 2 years working on modernizing the touch input stack for Windows, a lot of the touch platform work that you guys will see in the rest of the week, as well as working with our hardware partners to build great touch systems for Windows 8. And I'm happy to actually be here to share some of that experience with you guys. Joining me today is Takahiro and Steve. They work very closely with me on the team, and I'll let them introduce themselves before we start.
Hi, everybody. My name is Takahiro Shigemitsu. I've been also working in Microsoft for 15 years. I spent my last 2 years in the Windows organization studying, understanding the hardware's role to bring good touch user experience to the Windows. I'm excited to have this opportunity to be able to show you some of the work I have done in this space. Steve?
Hey guys, my name is Steve Welch, and I'm a software engineer in test, also on the Human Interaction Platform team. And I've been working with Takahiro and Jerry and also a number of our partners to help bring great touch hardware to Windows 8. So I joined Microsoft during Windows 7 to work on the touch input stack, and I was also heavily involved in the Logo certification program in that time span as well. And today I'm here to demo some new tools for you.
Great. Thank you, Steve Takahiro. So I see a bunch of you guys playing with this device. What you hold in your hands is actually a great combination of software and hardware. A lot of engineers work many months together with a dedicated team of hardware and software folks, and we managed to pull off a delicate blend to actually create this device. Now, in doing that, it reinforced a lot of the point of views in terms of how we believe touch systems to be put together, how they should be made, and how we could do it in a fashion that will reinforce the Windows 8 user experience. And what I'm here today is to basically share with you some of that experience, talk through how we're actually verifying the experience, and give you a peek into some of the tools that we use as well. So, if this clicker works, this is the agenda for what we'll talk through today. I want to draw your attention to what we want you to leave with. As I mentioned, we have a point of view on how these things come together. We really want to leave you with an understanding of what that point of view means, and also what it means to the hardware and software combination that it'll take to actually produce great Windows 8 systems. We also have done a lot of work understanding what users and developers demand out of the experience that we're building. And that's one of the critical components that has driven our point of view. So we want to share that with you. We want to also show you how hardware can actually meet these expectations and actually deliver on what we believe will be a wonderful touch experience that all our users will crave, and we'll all be able to build a rich ecosystem together. And of course, I talked about a little bit earlier, have a peek into the actual test tools and the way we'll actually do certification when we come closer to the Windows 8 release timeframe. So that's what we want to leave you guys with. So when we first took a look at how we wanted to build a touch-first user experience, we actually looked back a little bit into history. If you guys recall, Windows 7 was the first time we introduced touch as a mainstream input mechanism for Windows. Not only did we basically introduce that as an input mechanism, we also built up a certification process in the Windows 7 timeframe to really work with our partners to come up with a rich and diverse set of hardware that could address this space. But one of the things that was missing in the process was our ability to really closely match what was being done in the user experience side of the fence and what was being done in the innovation side of hardware. We wanted to closely link those things together, and we needed to basically establish that with a better understanding about what users need and what users want. So in developing Windows 8, we went back to a philosophy where we took what experience is that we're developing and had them drive specifications instead of the other way around. So we started with what we want to design, we want to build, and we want to perfect. And then we deduced a whole bunch of what was required to achieve those things. And I'll kind of share some of those with you. Because what we did in Windows 7 was somewhat in reverse order. We took some of the specifications, and then we kind of tried to fit it into what the experience would be. So that was kind of troubling to us. So that's where we started. Because when you think about what users expect out of software and hardware combination. They really need to figure out how it feels to them. And that's an aspect we spent a lot of time together. So let's start with the Windows 8 touch language. You've seen this in the different talks that have happened before. Jensen's talk yesterday, he talked a little bit about the touch language. And actually, there's a talk that's happening right now that they're going into the philosophies, the processes, the deep user research we did to come up with these. Now, this is actually a very simple set of touch languages because it turns out that human beings can't remember too much gestures. Because at the end of the day, you don't want them to have to remember a new language to use something which, frankly, the two hands that you're most familiar with to drive user experience. So when we actually did our user research and ended up with these 7, there are simplistic ways to actually allow us to build a whole operating system around. So you see us use this a lot in the entire operating system. This helps us kind of focus in on a unique set that people are familiar with. People kind of don't even need to think twice about. And it's something that's very easy for them to just hop on and use. Now, I won't go too much into the individual elements of this touch language. There are other sessions, and there are a lot of people who can talk better about these things than I do. But one of the key things and the key phrases you guys have heard, fast and fluid, is actually in how these touch interactions need to manifest themselves. And that's where, when we look at end-to-end touch hardware, we try to understand and look at it and realize that hardware needs to be the first part of the equation. Because when people use these touch interactions, the natural, fast, and confident manner which these interactions need to get pulled off is very, very critical. It is something that mirrors how they interact with the natural world today. Like, if you take an object and slide it around on a table with your finger, you expect to be able to move it any way you want. There's no second guessing. When you stop, it stops. It sticks to your finger. Now, that kind of interaction model is something that you realize becomes so critical when a user is interacting with a touchscreen, because in their minds, the thing that they've grown up actually understanding, how an object moves sticking to their finger, is instantly translated to the screen. To them, there's no difference there. It needs to work the way they expect it, and it needs to be natural, and they need to be 100% in control. If they lose anything, like if the object just doesn't feel right, they will know, and they'll realize it's something that's not working right. So that's where we started to do a lot of user research and try to figure out how to match that with great hardware. So user expectations are the way we kind of talk about these things. In Dennis's talk earlier, he talked a little bit about user expectations and around touch and how we qualify that. Well, when you read these things, you could also instantly summarize them and say, well, it's about performance, performance, performance. But we feel there's actually something missing if you just think it's performance. It doesn't adequately cover all the nuances of an experience. Each one of us are users, and when we use the device, we know what's missing. And when we went out and talked to people and just had them basically describe a great touch experience, they actually came out with a whole bunch of words that we were actually not expecting as much, like precise, compelling, immediate, seamless, efficient. All these things have little nuances that when you say just performance, they don't actually meet the bar, because it's not just about it moving fast enough. It's about it actually respecting physical models they may have in mind. Physics, for example. If you move an object on a table that's smoother than another table, there is a momentum they expect for the object to slow down with. And if you pan a page, it's the same thing. So as you use the devices you have in your hands, you see a lot of those natural interactions that are starting to get modeled in the system. Not only just in the pans you do within the start menu, the new start page, but also within the Metro-style Internet Explorer browser. Right? Those are very, very important elements of this. The other thing, as we talk about this space, and as we get into a situation where we're building a brand new platform, a whole new ecosystem, expectations need to be reset for what our developers really want. Now, developers really want to work in a world where they have the most opportunities, and no other operating system is going to provide them that. But the diversity of the ecosystem may not give them the ability to build an app that has the widest reach. So when we looked at the developer space related to touch, we kind of examined what really was needed in this space. Now, developers have told us time and time again, and this is something that really, really made a lot of noise about. They don't want to be the first to actually teach people how to use touch. They feel it's the job of Windows. And they feel that Windows needs to basically be the ones that overcome that barrier of interaction. So that's true. We have to take that responsibility. They also don't want to have to deal with the inconsistencies in the environment because they don't want to spend a lot of money and time just investing in that and not having the returns they want to. They also want to design for one modality of input and have as much as possible given to them cheaply or for free, right? And specific hardware makes them think harder about situations where they could be spending their time perfecting their applications. So we want to basically revisit this in the Windows 8 timeframe to figure out how we can actually remove all the barriers of creativity and give them and maximize the opportunities for them. This is something we learned pretty hard in Windows 7 because despite all the work we've done, modernizing the stack at that point, introducing touch as a mainstream input mechanism, you find there are very, very few touch applications built for the general audience. Vertical markets were great because vertical markets could actually control their environment a little bit better, but developers who were building for the broadest set of customers found it hard to distinguish and decide how their features and their apps would work between 2-finger machines, 5-finger machines, 10-finger machines. They were confused because they didn't know what they could count on, so they built extra code for that, right? They also had to deal with the nuances of each technology, trying to figure out which one could do the kind of actions they wanted to. They had no consistency when they built joysticks on the screen, for example, to try and figure out how to basically build great apps that work the right way. So in Windows 8, we're taking the opportunity to revisit this developer promise because that's a key thing that will allow us to build this ecosystem and welcome the immense amount of creativity in the apps that will come to this ecosystem. So that's a key important part when we design and figure out all these requirements, all these specifications that we have for Windows 8. So how do these things translate to hardware? Now, when we actually looked at this problem, we developed a set of kind of ideas about what it could be. Because we had a lot of user research, we had a lot of telemetry data that we collect over usages of touch machines in Windows 7, we formed an interesting point of view about what it is. But what was actually more interesting was to reach out to industry leaders and actually understand how these things would really translate into actual hardware. So we went out and looked for 3 co-engineering partners that led the way with us, that worked with us to basically push the envelope, not only in their currently shipping hardware, but in terms of how they see the future in terms of their chipsets and their business. Our partners, many of them who are here today, Wacom, Synaptic, and Atmel, have been the ones that have been working for months with us, actually up to a year at this point, pushing the envelope, trying new things, and actually building excellent products. And one example is the one that you guys received last night. So let me give you more detail about how that core engineering partnership worked, as well as how we start to deduce down some of these requirements. And Takahiro and Steve will get into more details about the others. So I'll touch on 2 things, pun intended, touch. And the first one is touchdown in terms of latency. And the other one, I'll talk a little bit about what we have mentioned over and over again in some of these talks about pixel level accuracy. So it turns out when you think about human interactions, and this is all a study of how a human being reacts to certain situations, it turns out that 100 milliseconds is the minimum amount, or is the maximum amount of time a user starts to realize that something is wrong, something doesn't react fast enough to them, something's just slow. That 100 milliseconds, through a lot of user research, really tells us a lot of things about how human beings expect of experience. So when we looked at that data, and we look at what happens in 100 milliseconds between a user touching the screen actually sending that information into the application and the OS, and then the resulting UI being painted on the screen, it really helped us understand this human perception around latency, slowness. And as it turned out, when we think about the developer, they become very, very important in this scenario as well, because you want to reserve in that 100 millisecond the maximum amount of time for the developer to do what they want in the application. I mean, if it's a game, it's thinking about where the sprites need to come out, right? If it's any other application, they need to actually process and figure out what's the next step to do. That's really, really critical for them. So if you take away that amount of time and then start to go, okay, so then how much is left for graphics to actually display? It's actually interesting because for graphics, there is more or less a common set of amount of time that you can't really walk away from, because graphic chipsets need to process the data, the graphic subsystem needs to render it to send it into the buffers, and LCDs need to refresh at a fixed rate. So for graphics, there's pretty much a fixed time there. And if for applications you want to reserve a reasonable amount of time, what you end up with is a 25 millisecond latency time that you need touch hardware to respond, from where the finger touches the screen to when the OS understands the signal. So that's where we formulated a bunch of these requirements. So we took that 25% and we worked with our partners. And it was actually one of our early and early discoveries that this was actually possible, because in some cases, some chipsets already was providing the kind of latency. But without that careful guidance and understanding of human behavior, people couldn't optimize. So with that kind of guidance, our three partners were able to achieve the kind of latency requirements that we want. So that's one scenario. Now, let's talk about the other one, pixel level accuracy. So you've heard about Edge UI, and if you've used your system much, you'll realize that that is core to our user experience. The edge is going to be something you're going to use every day, day in, day out, and probably hundreds and thousands of times a day, depending on usage of that tablet PC that you have. The Edge UI is a very critical part of the UI, but it also blows away a lot of the traditional assumptions about how touch hardware should be built. Because when you think about how touch hardware is today, a lot of the love is focused in on the center of the screen. A lot of the edges don't benefit from the kind of speed, accuracy improvements that folks have been pushing the envelope on. And that's one of the things that we realized very quickly when we decided that the edge was important for our user experience. The other thing that was very interesting as well as we designed the Edge UI was that it's once again a developer promise. Because every pixel you take to detect that finger getting onto the edge of the screen is a pixel that's taken away from the developer. So they can't place controls near the edge. They can't have people basically draw a full screen canvas. They will have pixels that are reserved there, and they will not be able to address that market they want to or be as creative as they want to. So that's something that was very important when we talked and when we started to think about this Edge UI. And because we had to blow past traditional assumptions here, our three partners, once again, was very helpful in helping us overcome that. They thought of new ideas, new strategies to allow that first pixel to become more sensitive and to benefit from all the capabilities that the center of the screen used to have. That's not something that can be easily achieved without close partnership. That's not something that's easily achievable without an intimate blending and understanding of how hardware and software works. And that's why, moving forward, that's going to be how Windows is going to work with the ecosystem, where we want to understand, we want to reach out, where we want to work together more on these capabilities. And as I said earlier, Takahiro and Steve will walk into deeper aspects of this, as well as some of the tests that we are basically building to verify these. So I spent a bunch of time talking about how hardware and user expectations and touch experiences come together. That is the focus of this talk. But I don't want to discount the fact that there are other elements here that are very, very important as well. Well, there are two things I do want to spend a little bit of time kind of giving you my thoughts on. But they're going to be much more that you see us taking a much more active role in recommending and directing the ecosystem towards. And it's not because we don't trust that you guys have the right ideas on where to go, that you guys don't know how to do some of these trade-offs that we point out. It's really more that we have benefited a lot from the user research. And I think it would be very beneficial for us to share more and more of that with you, to have you understand where we're coming from, right? So let's talk about trade-offs. So it's kind of interesting because when you think about the trade-offs that we're making to build great touch hardware, the same thing applied to the Edge UI example that I had before. You can also think about it from the 5-finger support. Now, Windows 8 will require a minimum of 5 fingers to be supported because we want to deliver on the consistency that developers want. We want them to be able to do multi-finger, two-handed actions and free them up from really being able to build as much creativity as they can to the applications. That's a very important thing. But we're also seeing folks going down a road where more and more finger support is like an arms race. But in any kind of these kind of arms race, you reach a point where you start making trade-offs that hurt the core experience. So let's say you have 10 or 20 finger support, but if you trade off latency, if you trade off accuracy to get that amount of finger support, what you'll find that developers will once again be in the old world where they're very challenged to depend and rely on a minimal set of fingers. So we would rather have responsiveness and accuracy with 5 fingers than actually trading off and building more and more finger support. That kind of differentiation is not a good trade-off in terms of people trying to just differentiate their machines because it hurts the ecosystem. It doesn't allow us to live up to that promise of great accuracy and consistency. So that's one of the trade-off things that you see us be a little bit more forthcoming and a little bit more direct in terms of how we feel trade-offs should be made. The other part is form factor design and device integration. So I'll go back to the example of Edgy. It's kind of one of our favorite ones now. If you think about how that human interaction for Edgy, it is that you have to put your fingers, you hold it in different postures, right? If you hold it with your thumbs, you're coming in from the edge. You could hold it with one hand and also have a finger come in from the edge. But all these things have a common interaction model where you're actually moving your finger from the bezel into the screen. Imagine a system with a tall bezel that your finger literally has to leap past in order to hit the insides of the screen. You will miss all those pixels within the LCD. So that's something that's really painful and disrupts the user experience because they won't able to hit the charms bar. They won't able to basically invoke any of the backstack flip stuff that we're doing. That's not good. So what we'd rather have is folks either leaving a buffer zone so that you have a bezel space that you have the finger originate from, or build a system with no bezel at all, flat bezel, right? That's something that you will see us be more direct in terms of recommending. We will also talk about how much bezel space is important for people to be able to grip their PCs well. This is kind of an inch right now, with a minimum amount of space before your palm actually contacts the screen. And you will see us being more active in trying to develop better ergonomics so that these PCs actually can be held and used very, very well. So those are the parts of device integration that you'll see us take a more active role in. And as well, I mentioned much earlier, in terms of tying and connecting the dots with the user experience, we will be shifting to a test for certification that focus all on user experience. Because as I mentioned earlier, the user experience needs to drive these specifications. And that's something that Takahiro and Steve will talk more about in their section. So at this point, I'd like to invite Takahiro and Steve to kind of get into the more details about some of our specifications and give you an idea of what we have in store moving forward.
Okay. Thank you, Jerry. Okay, thank you. So let's talk about how we test hardware in the context of user experience. This table shows a list of interactions that Jerry explained earlier. There are 2 additions to the list. They are compound interactions. And they are at the bottom of the table. There are typing and application experiences. Test cases we are developing are also divided into these categories. Today, I'm going to focus on a few of them. If I explain those interactions and how we test, I will take the following 3 steps. First, I will explain the user scenarios and its experience for the interactions. In the second step, I will talk about the corresponding hardware specifications to bring the experience for the scenarios to come alive. In the third step, I will show you how I explain the first two steps by giving the live demonstration of the tools with Steve. We have the device that was handed out yesterday. I encourage you to take out the device, and you can follow some of the example I will use during my presentation with me. Okay, so first is edge. So you heard Jerry talking about edge. You heard many people talking about edge in the keynotes yesterday. And you will swipe your finger from the bezel, from the edge, toward the center of the screen to bring up the charms. And you will use different fingers. Also, your finger swipe speed is different depending on the way you hold the device. So if you hold the device like this in the landscape mode, you're likely to use your thumb to swipe in. But if you hold your device with one hand like this, you're likely to use your finger on the free hand to swipe like this. In all cases, we want user to feel the charms, the UI, is actually dragged out from underneath the bezel. We want user to feel and have a very natural drag experience. The charms, the UI, is sticking under the finger as finger is swiped in. So let's tie this to hardware specifications. First is the edge accuracy. All pixels are accessible. So in order for user to feel the UI is actually dragged out from under the bezel, excuse me, we want to detect the finger coming into the active area of the screen as soon as finger hits the active area of the screen. And to do that, we do want to detect the touch data as close to the edge as possible. And we are pushing this to the very first pixel from the edge. This is where the all pixels are accessible specification comes in. Second is the response latency. And to talk more about the response latency, you need to know the speed of the finger swipe, because the speed of the finger is part of the equation to calculate the response latency. So we ran the study and we collected data. So in this graph, x-axis shows the speed of the finger swipe. Y-axis shows the number of samples we collected. And from this study, we learned that most of the swipes are between 20 millimeters per second to 200 millimeters per second. And under this speed, we calculated, if we can keep the end-to-end latency to 80 milliseconds or faster, we can actually keep the UI. We can draw the UI very close to the finger, and user will have a natural drag experience. The UI is sticking under the finger. Jerry talked to you earlier about the 100 milliseconds. That is the first down tap latency. Here we're talking about the panning latency for the finger dragging the UI. So out of 80 milliseconds, end-to-end, let me divide this up into three parts. First is a finger down, touching the screen to the time operating system receives the data. Second part is input stack operating system and the application processing the data. And the third part is showing the UI through graphics and display. And for this panning latency, it's about the first part. So out of 80 milliseconds, we are giving 25 milliseconds for the first touchdown data and 15 milliseconds for the subsequent data. And this will give a very natural, fast, fluid user experience to drag the UI. Now, I'm going to show you how we actually test this. Steve?
Great. So this edge experience is just really core to Windows 8. And I know it's kind of been drilled in over the course of the week, but I'm going to do it again, and not just because I practiced it. So I'm going to switch you over to my screen so you can see what I've got up on here. And I'm going to take you through what a typical user workflow might be like using these edge gestures, and I hope you've had a chance to try them as well. So for me, at the very least, I like to start off the morning reading the news on Twitter, so I'll tap on Tweetorama. Now, I'm not logged in, there's no Chrome on the screen, but I've used Windows 8, and I know that to get to these sorts of actions, I just pull up from the bottom. You'll see these little black circles following me around on the screen. And there's my login button. I'm not going to log into my Twitter account in front of everybody in the crowd right now, but you can see that's where this would happen. So as you're browsing through Twitter, you often find things you're interested in, and you're going to go and look them up in more depth. And I would do that in Internet Explorer. So I would pull out from the right to bring out these charms. I would tap on my start charm, and I would bring up IE from its application tile. So once inside IE, if I find something I'm particularly interested in, I might want to share that. I would swipe out from the right, tap my share charm, you can see Tweetorama has made itself available for this. If I were going to open a new tab, which I always do because I hoard tabs, I would pull out from the top. And if I wanted to get back to Tweetorama from here, I would pull out from the left and just pluck it right out of my backstack again. So we built a test to model this sort of interaction, and you can see how many times you would do it in a short space of time. And I'm going to bring that up now by going back to my desktop. So I'll talk to you about this floating window in a second. But what this test is focusing on is what Takahiro mentioned and what Jerry mentioned earlier, catching that first pixel, because that's how we give back the maximum real estate to developers. So there are a few interesting things going on here on the screen. Well, right now you're staring at a blank white screen. There aren't really many interesting things going on now, and you probably think I'm very easily impressed. But if I start moving here, you can see I get this green feedback when I've tapped successfully here, swiped onto the edge. And you can look at each of these green boxes at a time. I successfully brought up those charms, or else brought up a new tab in Internet Explorer. As I move through, you can see the tool keeps track of my success rate up at the top here. And what this floating window does, actually, is it allows us to configure the pixel that we're actually measuring at. So right now, we're measuring at 1 pixel. That's our goal. That's how we get that real estate. But this is a process, right? This is a tool to help you develop your system as you move along. And one thing we found really helpful as we've gone through this with our own partners is to just track our progress step by step. You know, can we hit 4 pixels? Can we get it down to 3 pixels? And you can use this to move along. And it's something we've gotten a lot of utility out of and a lot of good results out of. And I'm going to switch you back to Takahiro.
Thank you, Steve. So now you have seen one interaction example. I hope you were able to see how we deconstructed the user scenario and its experience to the hardware specification, and the way we test the hardware is in the context of user experience. So let's now talk about the tap. So this is one of the most fundamental touch interaction that we have in Windows, as well as the user will use on the applications. And tap comes in multiple forms, from a single finger tap to multiple finger tap, from single tap to multiple taps. Although the system, the Windows, only requires a single finger tap to navigate most part of the Windows, it is very important and critical that hardware supports multi-finger tap scenarios. For example, the Narrator application takes advantage of this. Narrator is an inbox application to help visually impaired users by reading the content showed on the screen. Inside the Narrator application, a single finger tap is read what's under the finger. 2-finger double tap is select and search. 3-finger double tap is read the available command. So it is, see, its application can take very good advantage of such scenarios. And let's now focus on the search UI on the right on the bottom. You can, again, do this with me if you have a device in your hand. You swipe from the right to bring up the charms and select the search tiles on the top to bring this up. These tiles are about 7 by 7 millimeters with a 2 millimeters padding. And when you do this, you don't want to try to target the tiles. This needs to be a very seamless and confident experience that you always want to be able to target easily. You want to be able to hit this 100% of time. Well, you may say that's not realistic if Windows uses a single XY coordinate to target the object. Because the finger you touch the screen is not a single XY coordinate, but it is an area, it is a geometry that touches the screen. Well, in Windows 8, we use a geometry data. We use contact geometry data to do the smart targeting. The picture on the right two tops, those blue ovals, those are the geometry data we receive from the hardware. We use this data to smart target the objects near the geometry. Well, now you may say, well, then we don't need the pixel accuracy. Well, that's not true. Because if for example, if the central coordinate of the geometry is inaccurate, the location of the geometry could be also inaccurate. Imagine the case of 2 close hyperlinks. Inaccurate geometry data can overlap more with the unintended hyperlinks URL, and you will be jumped to the page you didn't mean to jump to. Okay, now let's tie this to the hardware specification. First, in the table, accuracy and offset, 1 millimeter, all areas of screen. First, it's all areas of screens. The developer shouldn't have to worry about which part of the screen has more accuracy and try to put their UI at a certain location of the screen. That shouldn't happen. That's not necessary. And we use existing Windows 7 hardwares and Windows 8 prototype hardwares, like the one you have in your hand, and run studies. First, we run the tap test on the hyperlink test. With existing Windows 7 hardwares, the average success rate is about 74%. And the worst case was 60%. That is 4 out of 10 times user is missing to target the URL. With Windows 8 prototype hardware, it is showing the very good numbers right now, way above 95%. We also ran the studies on the 7x7 tiles on the tap test with Windows 8 hardware. And it is showing at 99.5% today. It is very promising. So let me show you how we actually test this. Steve?
Sure. So tap is everywhere, obviously, right? I mean, this is your main mode of interaction with objects on the screen. It's how you launch your apps. It's how you tap those URLs that are always so much fun to do on a touch screen. And it's anything you can imagine, right? It's tap. So I'm going to take you back to one of the examples Takahiro brought up, which is the search UI here on the side. So as I tap in, I get a view of all my applications. And these are those 7x7 millimeter tiles that he brought up. So he also brought up a situation where you'll have multiple fingers coming down at once. And I want to dive into that a bit. So we have a good example in the box with our piano application. And so when you've got something like this up on your screen, a great application, and you want to play a chord here, you have to bring 3 fingers down all at once, and all actually in very close proximity. If I play a minor chord, of course, it gets even harder to target. So there they are, and you can see that even though we have these challenges, it's really crucial that we continue to deliver clean input, because in this sort of situation, it would not come off very musically if we didn't. So I want to take you into a test for that first situation I brought up, the search UI. So I'm going to go back to my desktop. And, well, before I move on, I should probably say a few words about what you see on your screen. This is a sneak peek of our new certification tool. I think this is its coming out party, more or less. And what this is giving you is essentially a basket of crucial core experiences that you can pick from and test your device directly against that experience. So I brought up the tap test. Let's do that. You can see what it's giving me here is 7x7 millimeter tiles, exactly as you would find on the search screen, although you could configure that. And it just wants me to tap through them, which I'll do on stage. We'll see how that goes. You can see it's going pretty well. And the nice thing about this is that I know I can hit them here, and that means I know I can hit them back on the search screen. So I'm going to turn you back over.
Yep. Thank you, Steve. OK, so next one is slide. Pan, drag, swipe is part of these interactions. Earlier, I talked to you about the edge swipe. There is also one special case of this, where you are starting to swipe from the inactive area of the screen instead of the active area of the screen. And this is also using everywhere in both Windows and the application. Well, you will, for example, you will pan the tiles on the new Start menu to find the application you want to launch. Other example, you will use maybe one finger or multiple fingers to pan the contents inside the browser. While you're panning, you may do some short toss type of panning to quickly move from the top page to the bottom page. Or you may do more of the slide, where you keep your finger on the screen, you slide, you read, you stop for a while, and you slide again. So those are the examples of the user scenarios for the panning. And let's talk about the 2 specific cases that's on the screen. This is also talked many times during the keynote yesterday. The one on the top is a short swipe to select and deselect the tiles. The one on the bottom is a long slide to rearrange the tiles. And during this user scenario, during these operations, there are 2 things the user don't want to see happening. First, so let's talk about this long slide one, right? In this case, there's 2 cases. One is the user don't want to see a panning happening, the horizontal panning. user is confident that he wants to rearrange, so his finger is moving up or down, it shouldn't be confused with the horizontal panning. If there's a jittering, it will actually cause a horizontal panning. And second thing the user don't want to see in this scenario is a tile being dropped as unwanted, unintended locations. During the tile rearrange scenario, user will move the tile in different speed. He will stop for a second to find out exact location to drop the tile to. The tile should stay under the finger as long as finger is kept on the screen. There could be other fingers on the screen during this slide operations. You take out the tile to rearrange. You use the other free hand to pan from the one group of the tile to the other group and to find the exact location to drop to. Okay, so, excuse me. Make sure I cover. Okay. So let's tie this to the hardware specification for the contact tracking. So contact tracking is where hardware assigns a unique contact ID for the finger that is placed on the screen. So for example, if you place one finger on the screen, you may be assigning a contact ID A. Finger may move to different directions, different speed, may stop for a second, but contact ID A needs to stay with that finger. If you have 5 fingers on the screen, you will be assigned unique ID for it, such as A, B, C, D, E. And that IDs need to stay with each finger. Finger may come close, diverge, converge, but we want the finger to stay. The ID to stay with the finger as long as the finger is kept on the screen. So now, let's see how we test this. Steve?
Sure. So let me hop back over to this screen. So Takahiro brought up a few examples of slide. And one really common one, of course, is just being in your web browser. So as you're browsing, in a sense, you're kind of always doing these slide gestures, right? You'll have a finger down. You'll be going a few lines, bring up new text. You'll toss to the bottom or back up to the top. Back on your start screen, here's the edge again.
Yeah.
What you'll be doing is panning left and right to get through your application tiles. We also brought up a couple interesting new things we have. So you can select an application by tugging down on it like that. This will bring up things like uninstalling the app or pinning or unpinning it. You would deselect it in the same way. And then, of course, personalization is always kind of a big theme in Windows. So I'm going to try to look over there, too, but I'm a little blocked. So for instance, I use InkPad a lot. So why don't I move it a little closer to the beginning of the stack so I can get to it more easily? I'll put a second finger down and then bring it right up here. So what I want to show you in terms of tests is these last two situations, select and rearrange. So I'm going to come back to my desktop, and now I'm going to pick out this select test. So my goal here is to pull down on this blue tile in the exact same way that I was doing on the start screen just a second ago. So I'll go through a couple. Can pan up or down, and it'll work the same way. And what this is watching for is those things that will really sort of spoil that experience back on the start screen. So it's going to watch for jitter, which I'll try to simulate here. And you can see it actually simulates that panning you would see on the page as well. And it's going to watch for things like contact drops, which will interrupt that gesture. So that's one of the worst things that can happen, right, from a user perspective, where you feel like you've done all the right steps, but you didn't get the result that you were expecting. And I want to show you our rearrange test as well. It's very similar. Now the goal is to drag past this gray line. And what that gray line represents is the threshold where a selection becomes a rearrangement. So again, it's watching for some of the same things. It's watching for jitter, which causes panning. But of course, rearrange is actually a lot more sensitive to the contact tracking issue. Because as you rearrange something, you're not entirely sure where it's going to go. You have second thoughts. Is it a game? Is it a utility? Where do maps go? And that's a lot of opportunities for things to go wrong. Now, a nice thing actually about all of these tests is that they're using the exact same logic that the operating system itself uses. So when I pull this down and I rearrange this tile, I am rearranging this tile the same way I'm doing it on the start screen. It's the same thing. Another nice thing is that we're always collecting data. It's a very powerful logging mechanism that's built into this. So that means that over time, we can look at this data, and we can use that to tune our operating system to work better on the devices that you're building. And those are a couple of cool things, I think, about these tools. I'm going to send you back over to Takahiro.
Great. Thank you, Steve. So So I do have a slide. I have prepared a slide for the hold and manipulations. But since we are short on time today, I'm going to skip to typing. This is a very good example for the compound interactions. So you have, like for the device, like the one you have in your hand, touch typing is very important. Some people may only choose to type a very short phrase in the social application like Facebook, but some people may actually write a novel with the devices. Today I'm going to focus on 3 unique characteristics of the touch typing. They are, first one is the typing speed, and second one is the finger hovering very close to the screen, and third is the rapid taps at the close locations. Let's talk about the typing speed. On the physical keyboard, average typing speed is about 40 words per minute. That is about 3.3 keys per second. People like you in the audience, myself, who types regularly, types between like 70 to 80 words per minute. That's 6.6 keys per second. Although these numbers are from the physical keyboard, people are starting to touch type close to this speed these days. And second example is a finger hovering very close to the keyboard, very close to the screen. So if you have the device with you, you could actually bring out the touch keyboard and in the full layout, and you can try to touch type. And you will see your 2 thumbs are hovering above the space key, space bar, very close to the screen. As you touch type, as your other finger tapping, your thumb is coming up or down very close to the screen. And you don't want to have accidental unintended space inserted while you're touch typing. So this is where hardware specification of the maximum z-axis allowance for the touch detection, 0.5 millimeter comes in. As long as the finger is kept up above 0.5 millimeter from the screen, hardware should not register a touch. We did not have this in Windows 7. When we studied the user experience for the touch typing, we discovered this requirement was missing. So let's see how Steve could type.
Sure. So I'm going to have to switch over to this contraption now. I'll just bring that up for you. All right, how are we looking?
You may want to refocus.
Sure. Let's just pull out a bit. All right, so we've got a screen.
Can you focus? Can you focus?
Would you like me to focus? All right. Everybody hold on. Focus break. Get some focusing music.
No, I don't sing. Right.
At any rate,
All
we're
right.
going to stick with that.
Okay.
And I'll just talk through it as much as I can. So let's get that centered on there.
Okay.
And now I'm going to do one of the worst things you can do on stage, which is try to type in front of a full room of people and on a touch keyboard. So what I'm going to do is go back into this search menu and just pull up WordPad. Pretty classic. So I'll zoom in so you guys in the back can see. And I'm going to bring up our touch keyboard. So let's just find something to type. Look, it's obviously very crucial we get this keyboard experience, right? Because more and more you really want to live on these sorts of tablet devices. When you're off on the road, and I've been out here for a week, for instance, living on this, you want to be confident that you can just bang out those quick emails, that you can keep your friends posted on your social networks. And you don't really want to dread having to go into this soft keyboard to do that. You don't want to feel like it's a barrier to the thing you're actually trying to do. Let's just dig into it and see where we are these days. So we can type, the rain in Spain falls mainly on the plane, or the plane, for this matter. So I've injected my own typos, obviously, but sort of the thrust of this is just that I can type confidently at that speed, and I make typos on a hardware keyboard, too. We can try other things. Hey, do you have some time to go over our slides?
Wow.
And clearly this isn't really this is not a typical case so much for typing, but as much as that's true right now, more and more it's not going to be the case. Everybody has a touchscreen device. We're all getting really rapidly acclimated. And already this is becoming the expectation when you sit down at a software-driven keyboard.
So clearly he types much faster than I type, and really fast. So let's talk about the last characteristics. So this is about 2 rapid taps at the very close locations. So now I'm going to ask Steve to type doctor.
Sure thing.
So if he typed doctor, he has one finger on the shift key as a holding, and he has two other fingers. All right, time's almost up.
Warning.
All right. He has two other fingers tapping on D and R pretty fast. And when he taps on D and R, those are overlapping. So now I'm going to ask Steve to type dressed as.
Sure thing.
Cool. Fast. So when he does this, there are 5 keys, right? D, R, E, S, A. They are very close to each other, adjacent to each other. And when there are 2 rapid taps at the close locations, hardware is often confused with a single finger move. But user is sure he tapped twice, not one move. And if this happens, the key is missed. It's going to slower the typing experience. And as I'm talking, Steve is having fun. That's good.
Nope, nothing.
All right. But as you can see, it is very important that we could distinguish the 2 rapid tap versus 1 finger move. Okay. Thank you, Steve.
No
Can
problem.
you switch?
Yep. It'll.
All right. So I'm going to wrap up my part of the presentation with this slide. This is about us working together, the reinforcement that we do need to work together to build a strong ecosystem. As Jerry explained earlier, developers should not have to target a specific type of hardware. The application should run on all range of the form factors, from the small devices like the one you have in hand, Slate, to the bigger form factor like all-in-ones. To guarantee such experience, the consistency and quality of the hardware specification is very important. We will test this consistency. We will test, for example, 5 minimum good responsive fingers for all Windows 8 touch devices. So Steve, can you toss me the finger?
Yes, I can give you the finger.
All right.
There you go.
So as you've seen, this is our popular finger in the company right now. We use this to measure the touch hardware latency. You saw, I think some of you saw in the keynote yesterday. And with this, like this type of testing and some of the test cases Steve showed, this is just a part of the big test cases we have built, we are developing right now. And we will make these test cases available to the ecosystem. And now, Jerry's going to come up and talk to you about when and where you can get these tools. Thank you.
Thank you, Hiro. Thank you, Takahiro Steve. So you've now seen how we kind of deconstruct a lot of our user experiences and how we built test tools to actually verify them. You have also seen our famous finger there, and if that will stop beeping, I can carry on talking. So I want to spend a few minutes just closing out and talking a little bit about Windows certification and what that means. So as I mentioned earlier, the specifications were driven by us working very closely with our hardware partners. And the 3 partners that we have, Atmel, Wacom, and Synaptic, really helped us drive and push and understand what this hardware is capable of. And it can be done. They have shipping products, they have existing chipsets, and they're all here at the Expo Hall and can ask them all about their experiences working with us. So it's one of the key things that have driven us to this point. But we also know that the touch ecosystem is always innovating. And in terms of innovating, there'll be more and more people that can meet these requirements. That's where certification becomes super important. And that's where certification becomes your route to help us understand how you can actually meet these requirements and become Windows 8 certified. So when will we start certification? Our plans are to start this, taking submissions somewhere in around the RC timeframe. And we will actually be part of the hardware certification kit beta, where you'll see a lot of our tools come out, and you can start using them for actually testing your own hardware. So that's what we'll actually talk more about as we hit the beta milestone and introduce more and more of these tools to you guys. But one thing I want to close out with is also talking about the submission model. Now, the submission model is going to be very familiar if you're already doing Windows 7 hardware today, with one big change. And I want to talk about that change. Change not talked really clearly about in the slides, but I want to make sure you guys know. In our learnings in building Windows 7, one of the key things we learned was that the end-to-end and the trade-offs are super important. So when we actually want to test hardware for the Windows 8 timeframe, we want to kind of change how we think about the hardware that we're testing. So what we want people to submit when we open up submissions is a combination of the touch module in a working system. Because That's the only way you can see touch working in the native environment and can truly understand all the trade-offs that are being made. For example, where you put your RAM, where the power supply of a system goes, where the shielding and the LCD are placed in the system, all impact touch. Therefore, we do want to see it in its native environment so that we can really understand what our end users will see. That's super critical and a big change for the submission process. We'll get into more details about that, and we'll publish more guidelines about what we mean by touch module. By no means is that a way for, or a rule or something to kind of push you towards developing your hardware in a certain way, but it's more to be in sync in terms of terminology. A touch module to us is basically ITO, cover glass, LCD, chip, right? And that's something from a simplistic point of view, we want you guys to be in sync with us and to be able to submit your best products to actually address that space. So that's what's changing, but the workflow will remain essentially the same. You will submit to a Taiwan test lab, and they will certify that using the tools that you've seen today. Over time, you also see us introduce more robotics into this space, where we will introduce robot tests that will scale up our submission process, and we will also publish a lot of our specifications for robots for you to actually get them into your environment as well. That's very important for us and yourself to get right, because that's the only way we can build this ecosystem together. So just to quickly recap, you heard about me talking about natural, fast, and confident. And that really only comes true if we're able to jointly work on and build great hardware together. And you've heard about these user expectations that we have spent a lot of time researching and understanding, as well as that new developer promise that's so critical to build a new ecosystem. And we've also shown you how to test it for it. And ultimately as well, how you can get ready for it is that certification will start soon. So you may ask, what should I do? Well, if you're an OEM or a hardware manufacturer that's touch solutions, get familiar with the certification process. Get familiar with the hardware certification kit. There's several sessions that I'll talk about, the next slide, that you should go attend. If you're a developer in the room, understand the hardware promise that we're making with Windows 8. We want to allow you to build the most creative apps that you can imagine, and we want you to take advantage of the widest reach and the biggest opportunities in the Windows ecosystem. If you're a user, and all of us are users, we want to make sure that each and every one of our user expectations are met. And it starts with great hardware. So that's something that we hope all of us will be able to achieve and really bring Windows into a very touch-centric world. So here are some sessions that I mentioned earlier. If you're basically dealing with certification and want to basically get familiar with it, do attend 260, 719, and 659. The whole touch platform is also being discussed in many, many different talks. I've taken a few out here and point out a few. 391, 182, 185, 186 are very interesting talks to go attend. If you're thinking about differentiating your product with a pen, we have brought the pen into metro-style applications as well. Attend 192 to find out more about what we have brought into that space, because that's going to be an exciting space as well, because you can actually design for touch and get mouse and pen for free. So we'll see more of those apps come to the forefront. So thank you for your attention today. I hope I'm leaving you with a whole bunch of information that you can go follow up on. The three of us will actually be in the expo hall after this talk if you have any questions. So feel free to come up to us and talk to us. Our three partners are also there as well, so you can ask them questions as well. But appreciate the time you spent with us, and enjoy the rest of Build Conference. Thank you.